Good morning, friends. I am Professor Yogesh Hangi, going to teach you a very interesting subject. Name of subject is Database Management System. Database Management System is DBMS. Friends, today I am going to teach you first unit of this DBMS. Name of the unit is Introduction. The content of the introductions are clear. Introduction to Database Management System. Then purpose of database systems. Next is database system application, then view of data, next is database languages, after that data system structure, then data model, after data model, next content is database system design and ER model, which contain entity, attributes, relationships, constants, keys, design process, entity relationship model. Next is ER diagram and design issues. After that, extended ER features. And last is converting ER and ER diagram to table. We'll move to our next slide. Yes, see the next slide here. We will start the study of this DBMS subject. While studying, the first question that may arise in your mind is that what is database? Yes, friend, what is database? A database is a large integrated collection of data. And second point, database is collection of related data organized to meet the needs of organization. Yes, it is collection of related data organized to meet the needs of organization. For example, the roll number, the names, branch, subject marks, average mark of students of your college. This is one example. The second question that may arise in your mind is that what is database management system? What is DBMS? DBMS is the software designed to store and manage the databases. It is software designed to store and manage databases. Now we move to the next slide. Friends, in this slide, we are going to see the purpose of data management system. Here, data can easily access. Data can be easily accessed, retrieved, filtered, sorted, and updated. Yes, friend. The purpose is data can be easily accessed efficiently as well as conveniently. The first purpose of database management system. The second purpose is to store data systematically. To store the data systematically. Then third one is enforce information security. Information accessibilities are here. Database security, concurrence control, crash recovery. Okay. Now after that, we're going to see the database application. See the first example is railway. In railway, there is database for reservation schedule. After the second example is university. In university, in universities, there is use of database for admission, result, and other type of purpose, other tasks. Then well-known example is banking. Banking uses DBMS for all transaction of customers. Next example is sales. The DBMS to store the data of customer, to store the data of products, to store the data of purchases. And one more example is human resources, HR. The DBMS to store the employee data, salaries, tax details, etc. Now we'll move toward the next slide. view of data. Yes, friend. In this slide, we are going to see what is view. See, well, my friends, abstraction is one of the important features of database. Yes, abstraction is one of the important features of data systems, hiding irrelevant details from the user and providing abstract view of data to users, help in easy and efficient user database interaction. Abstraction. You already familiar with the abstraction. Abstraction means hiding irrelevant detail and providing abstract view required data to user. Okay. It helps in easy and efficient user database interaction. Now here we are going to see the level of abstraction. There are three levels of abstraction: physical level, logical level, and view level. First we'll see the physical level. Physical level is bottom level. It describes how system actually store data. It describes complex data structure in detail. Yeah, up to physical level. Above the physical level, logical level is there. It describes the data stored in database and the relationship among those data. DBM is this logical level of abstraction. DBM is database administrator. Above the logical level, view level is there. This top level. Application program hide detail of data types. Application program hide details of data types purposes. It simplifies the interaction. It simplifies interaction with system. Users access only part of information so that different users use the different view of same database. Now we'll move on to the next slide. In this slide, we are going to discuss the database languages. DBMS has three types of languages. First one is data definition language, DDL. It is used to create, delete, or modify database schema. It is used by database administrator, DBA, to specify the conceptual schema. DDL makes changes in schema. Example of the command in DDL are create, alter, and drop statement. Example for create command. Create command. Create table employee. EID number 4. Number bracket 4. Ename bracket 50. Then salary number 5. In this here we are going to create the table employee having the column EID, ename, and salary. That, that employee table. Then example for drop count, drop employee, drop. But we are removing the table from data, drop. Then example of alter command, alter table. Here example alter table, the name of the employee, and add column. We are going to add one more column to the existing table. The name of column here is address, rather 20. The next language is data manipulation language. Data manipulation language means DML. DML is used to insert, update, delete, and retrieval of data from the database. It reflects changes in instance, not schema. Instance means record, the row of the table. Example of this DML commands are See, insert, update, delete, and select. These are example. Now we'll move toward the next slide. The third language is DCL. DCL means data control language. Used to control access to data stored in database. It is used to control the access to data stored in database. It includes commands such as grant and revoke, which mainly deal with the rights, permissions, and other control of database system. For example, grant. Grant gives users access privilege to database. It gives users access privilege to database. And next command is revoke. Withdraw users access privilege given by using the grant command. Just opposite to the revoke is the opposite to grant command. Grant command gives the access privilege to user, and withdraw revoke withdraw the user's access privilege that are given by using the grant command. Now we'll move toward the next slide. In this slide, we are going to see the components of the structure of DBMS. We are going to see the structure of database management system. Yes, ma'am. Database contains huge amount of data and handling multiple requests from user simultaneously. It should be arranged properly. That's why it should be arranged properly. Okay. That's why the structure is important. Now here we are going to see the components. How we can say the components are elements. Yes, friends. Components are elements of the structure of DBM. Different elements are there, different components are there. Okay. We are going to discuss this the components and or elements of the structure of DBM. First, application. Second, end user. Third one is DDL. Then next, fourth one is DDL compiler. Then fifth one is DML compiler. The sixth one is query optimizer. And seventh is data files. Eighth one is data dictionary. Ninth is data menu. One more we see this component or elements of the structure of DPM. The first one is application. Application is user-friendly application which enter user request or which can accept the user request. Example is website. Then second is end user. End user means real user of database. Example, developer, administrator, actual user. Third element or component is DDL. It is used to create database, schema, table, mapping, etc. in the database. Create structure of the database. Example, table, indexes in the database. Then fourth one is DDL compiler. It processes DDL command. It breaks the command into understandable code. Consisting metadata like table name, space used by, etc. Then fifth one is DML compiler. To understand DML command, it breaks those command into object code. To understand DML command, it breaks those commands into object code. Then next element is query optimizer. Query optimizer. Decide the best way to execute the user request which is received from the DML compiler. It just decides the best way to execute the user request which is received from the DML compiler. Then seventh component and data file. It stores real data, example optical disk, magnetic disk, magnetic tape, etc. Then seventh component, sorry, eight component. Data dictionary. Data dictionary. It contains all the information about database. It contains description of all the tables, view, materialized view, constraint, integers, triggers, etc. It permits the user to access data. It is like a data management tool or data glossary. Then ninth element is data management. It is control system. Convert the request received from query optimizer into machine understandable form. It maintains consistency and concurrent access of data. Yes, data management is a control system. Convert the request received from the query optimizer into machine understandable form. It maintains consistency and, and concurrent access of data. See the structure of DBMS on diagram. Application, end user, application to DML, compiler, query optimizer, end user connectivity, DML compiler, query optimizer, DDL, connectivity, DML compiler, the DML compiler, query optimizer, DDL, compiler connectivity to the store data manager. Store data manager connected to data file, compile DML, data dictionary. This is diagram. Now we move toward the next slide. Data model. Data model. In this slide, we are going to see the data model. Okay. Underlying the structure of DBMS, sorry, underlying the structure of database, data model is there. Here model, not data model. Okay. It is collection of conceptual tool for describing data, relation and relationship among data, data semantics, consistency, constraint. It is all about the data model. It is conceptual representative of data structure. It shows how data is organized in database. The next point is way of design describe a physical, logical, and few level. Way of design describe at physical, logical, and few level. Next, next point. To overcome restriction of relation model, researchers have developed several data models. Example, object-based data model, semi-structured data model, etc. Data model. There are different types of data model. Relation model, relational model, entity relationship model, and object-oriented data model, semi-structured data model. One by one, discuss this data model. First is relation data model. Model was proposed by E.F. Quad to model data in the form of relations or tables. Proposal of E.F. Quad. Then next one is provide a method for processing data and queries. It provide a method for processing data and queries. After design the conceptual model using ER diagram, we can convert that conceptual model into relation model, which can be implemented using any any RDBMS, DBMS language, RDBMS language like Oracle SQL, MySQL, and etc. Continue. Elements of relation model. Here, relation or table. It consists matrix composed of intersecting tuples and attributes. Relation. It is also known as table. It consists of matrix composed of intersecting tuples and attributes. Tuple. Tuple is also known as rows. It is single row contains single record operation known as tuple. Then next attributes means column.